Good morning, everyone. I'd like to introduce myself. My name is Fatih Darmawansyah. I'm from Republic of Indonesia Defense University, Faculty of Health and Science. First of all, I'd like to extend my gratitude toward the honorable judges and Pramakuklau Medical College for having us here so I could present our research about comparative study of classification algorithms for miRNAs related to endurance sport and measurement of candidate miRNAs. So let's get into the introduction. Us cadets are expected not just to be a scholar or a soldier. We're expected for perfection. We not only just a knowledgeable scholar, but also we're ready to face combat situation, and that needs a high physical endurance. Now, previous studies about ACE genes have shown that ACE ID can be used to identify the genetic preference for endurance training. It's essential for elite troops or us to be assigned to the military. However, it's only just that. It's only for genetic preferences, not to monitor the training progress. Now we're going to use miRNA as it can reflect the physical activity and serve as training biomarkers. So as we all know, the miRNA's data expression is kind of complex. So we're going to need something that can analyze it faster and better. That's why we're going to implement machine learning this time. This study aims to compare machine learning algorithms for classifying miRNAs and integrating molecular technologies with machine learning. And we're going to develop precise biomarker to optimize physical and mental performance while preventing injuries. Now let's get into the methods. We got our ethical clearance from Ethical Committee Faculty of Medicine and Health Science, Republic of Indonesia Defense University. And then we're going to analyze the GEO datasets using 3 different machine learning models, KNN, SVM, and random forest. And then we're going to take blood samples from the subjects and then implement an intervention by 8 weeks. 8 weeks training regimen consists of 45 minutes endurance training, 4 days a week. And then we're taking another blood samples to see the miRNAs difference and to analyze the expression data using the determined machine learning models. Onto the results and discussion. After analyzing the miRNAs expression using the mentioned machine learning models, random forest shown to be the most effective model, showing the 66.67% accuracy. And even though it has a longer time, its strong precision and recall makes it best for classifying training status. SVM show high recall but low AOC ROC, and KNN has higher AOC ROC but lower accuracy, making it less reliable. Onto the miRNA candidates, we found that HSA miR5325P reveal a slight increase in the expression after the training from 66.22 to 6.48, and the miR29B variant, especially the miR29B 25P, showing modest increase in mean expression. However, there's a variability in expression in miRNA, making it not very optimized for now, as we only have limited subjects. In other studies, it was shown that overexpression of miR5325P in ovarian cell cancer significantly reduced the cell viability, making it a potential biomarker and tumor suppression in ovarian cancer. And miR29B25P is related to PSEN1 gene and amyloid beta production, which observed in patient with Alzheimer's disease. In conclusion, our first conclusion is the best machine learning models to use in analyzing the miRNAs data expression is random forest, as it have the best uh, analyzing capabilities and high ROC and high accuracy. And then we have the miRNAs candidate. It's the miR29B25P and miR5325P, which significant in muscle adaptation. And then the combination of the machine learning and the candidate miRNA shows promise for monitoring training responses and optimizing personalized exercise program, and will make us able to monitor the training and prevent injuries for further cadets. Thank you.
Thank you for your impressive work. Do you have any comments or any questions?
So you use miRNA to predict the endurance, right?
Correct.
So how do the how the MIR relate to the endurance in the people?
All right. So first we analyze the miRNAs using the machine learning model to see which among those three that I've mentioned before that's the best in analyzing the miRNAs data. And then we're doing our own research. We're analyzing the miRNAs data expression before and after training. So before training, we're taking the blood samples from the subjects, and then we do an intervention by 8 weeks training program about regarding the endurance training. We're doing 45 minutes a day for 4 days a week training for 8 weeks, and then we're analyzing the miRNAs data expression. And based on, as we know, random forest as the feature importance ability, it could identify which of among the lots of miRNAs that's really affected by the endurance training. And as we've done the research, it is HSA MIR29B25P and MIR5325P. So we do the blood sample taking, the training, and then another blood samples to see how it differs from before and after training.
There are more questions from the online judge.
Actually, why 8 weeks is the first of my question. Is that enough for the time for the training for the endurance? The second one is that currently, do you have any standard measurement for the physical test for the endurance already? Why would the miRNAs is needed to test molecularly? I'm not quite clear. It is interesting scientifically, but the real application, I think perhaps you can test physical endurance by the physical test. I mean.
Okay, thank you for your question. So, based on the previous research, there's a certain time of endurance training that could affect the miRNAs, and that's roughly around 45 minutes. So, we're having the 45 minutes based on the previous research. And how is this going to apply in the future? So, so far we can only use the tiredness scale for students to know if they're tired or not, if it's maximized or not their training. So we're going to use miRNAs because miRNA is like, you can analyze it numerically, not just by how do you feel about the training. And that gives more accuracy on the data results.
Thank you very much.
Yes, thank you.